Try that again. All right, hyperbolas. Here we go. Alrighty, so here we go. When it comes to the hyperbola, when you think of an hyperbola, the best way to think of it as an inverted ellipse. So what I mean by that is this is our traditional ellipse that we just did in the previous section. What a hyperbola is, it's taking what was the ellipse and it's like splitting that oval like in half, and it can either open left and right like that, or it can open up and down. Essentially, the hyperbola looks kind of like two parabolas going in opposite ways. Again, it's either a pair opening up and down or a pair opening left and right. There's a definition. With the hyperbola, just like with the ellipse, there are two axes of symmetries. There is a slight different verbiage for the vocabulary, and the transverse axis is basically what we were referring to in the ellipse as the major axis. It's going to be the longer of the two axes, and that's the one that's going to connect with the A, the A that's in the denominator. And then we have the conjugate axis, which is essentially the minor axis. I'm not going to require you learn the new vocabulary. I'll still have in parentheses for anything minor and major axis, so you'll still know what these terms mean. But I do just want you to be exposed to them. But again, knowing the minor and major axis is fine. The center is still HK, and the center is the point where those two axes intersect. So that's our center there, HK. And the axes are still perpendicular as they were with the ellipse. Just to review the vocab, the vertices are the endpoints of the major axis, and the co-vertices are the endpoints of the minor axis. All right, or the conjugate axis, etc. All right, so let's move on to the next slide. All right, so here we go on this slide. I would pause this for a minute and just make sure I took down all of the formulas I need to know, because you'll need to know, these different formulas for the foci, the radii, the co-vertices, and the asymptotes, etc. So again, I would take a second and pause the video, write all those down. Excuse me. So when I get to some of the future examples, I have them on hand. All right. So basics here. The main difference, again, with the hyperbola and the ellipse, they are very similar. But the main difference, or not the main difference, the only difference with the equations is the fact that there's a negative. One of those x squared or the y squared is going to be negative. And that's what makes it not a joint shape, but that's what makes it like separate and become disjoint because of the negative. Anyway, when it comes to the other things, all of these are the same. The focus, the foci, the radius, the vertices and the co-vertices. But there is going to be a difference in terms of how the graph comes out. So let me elaborate on that. You're going to end up with a box when it comes to the hyperbola. That box is going to be a combination of, first you would do your major axis, your A, and you start from the center, and then you would go over A that way, and that gives you your major axis. Your minor axis, again, now these could be horizontal or vertical, it depends on the problem. Your minor axis would be the other one, and these are your co-vertices at the ends of that. Now, with the hyperbola, you want to make a box that kind of closes all that in, and that box that closes all of that in will end up being how you get your asymptotes. I think we spoke about asymptotes 1 or 2 times this year. Asymptote is a line the graph does not cross. I shouldn't say does not, like it won't cross ever. It won't cross. And when it comes to your asymptotes here, here's the equation for getting that. That equation looks crazy difficult. I know it's probably a little bit like, what? But it's actually point slope form. You guys may or may not remember point slope form from Algebra 1, but that's when the equation looked like this. It was like y minus y1 equals m, then it was x minus x1. So it's a formula you've seen before, but we don't really look at this form too much. But anyway, so that's why it looks like that. But basically, all you're going to do is make a line going through the endpoints of the diagonal that's going to pass through that square, that rectangle there. So the endpoints of the diagonal etc. So those are going to be your two asymptotes. I'm probably not really going to require you do all the work for the equation, but do know how to do it for a graph. All right, so this first slide here, where we're doing some work, we're just picking out the part. So I just want you, excuse me for yawning, identify the center, A, B, and which way it opens. So let's do that quickly from the table. If you want to pause it, you can, and try it on your own before, seeing what I write for the answers here. For the first one, the center is going to be 3, 5. Again, the center is always opposites for H and K. And A is going to be 5, because remember, this is A squared, this is B squared, and B is 4. And the graph in this case is going to open horizontally. And again, the reason it's horizontal is because, essentially, it's just because the x is positive. Excuse me. So it's not quite like the ellipse. The ellipse, had the orientation kind of based on where A was. When it comes to the hyperbola, the opening, the left, right, or the up, down is going to be based on which one is positive. All right, next one. For this one, be careful. A lot of the times people will not, they'll write this as 2, -1. But again, you want to be careful because since y is first, this is the h with the x. So that's h and that's k. So it's going to be -1, 2. Again, they're always opposites. And then we have 6 and we have 3. And this one, because y is positive, it's going to open vertically. For the next one, same thing. Again, this is h, this is k. So it's going to be 5, -2. A is the square root of 3. Now, a lot of you might say 0 for B, but what's actually under a fraction if there's nothing there is 1. And the square root of 1 is 1. And then this would be vertical as well, because the y is positive. And then the last one, our center is going to be 0, -4. This is 7. This is the square root of 8. I'm fine with you leaving it like that. If you simplify the radical, that would be 2 root 2. And this one would be horizontal. All right, next slide. All right, so now let's begin the fun stuff. From the equation, we're going to want to identify the center, the vertices, co-vertices, foci, etc. So the orientation, x is positive, so it's going to have horizontal. I really shouldn't say orientation. In this case, I should say the way it opens. But I just use the same table I use from the ellipses, so that's why. Horizontal. The center here is going to be 5, 4. Excuse me. Because A is under the x term, it's going to affect the h, the x coordinate. So it's going to be h plus or minus a, comma, k. And that means my co-vertices will be affected. The k will be affected. So that would be plus or minus b. And I'll just go ahead and write. I should have just wrote what a and b were. But a is 5. And b is 2. Excuse me. So it's going to be, sorry, I have the yawns. It's going to be 5 plus or minus 3. Why did I write? Is that supposed to be a 3? I don't know why I wrote 5, sorry. 5 plus or minus 3 there. And then over here, this is going to be 4 plus or minus 2. So my vertices are going to be 8, 4 and 2, 4. 5 minus 3 is 2. 5 plus 3 is 8. And the next one is going to be 5. And then it's going to be 6 for the first one. 2 for the second one. And the foci are going to be, excuse me, again, hopefully you wrote down the equation earlier. It's going to be h plus or minus c, comma, k. So c for this one, we get c the same way as we did with the ellipse. So it's c squared equals a squared minus b squared. So it's 9 minus 4. So we get c squared equals 5. So we square root it. So c is the square root of 5. Excuse me. And the square root of 5 is approximately 2.2. Now, for graphing purposes, I don't always really care if you put the focus or not. But again, there might be a question or two that asks you for the focus. So you do want to know how to find it. But again, it's not necessarily of crucial importance to the graph. So it would be 5 plus root 5, comma 4, and 5 minus root 5, comma 4. If you wanted to plug in the decimal and get the decimal, perfectly fine. All right, let's look at the graph. For the graph. Sorry, I can't stop yawning. We'll start with the center. Center is 5, 4. So 5, 4. Then we'll do our vertices. Our vertices are going to be 8, 4, and 5, 2. I'm sorry, and 2, 4, sorry. So this is our major axis. And let's do the minor axis. Our minor axis is 5, 6, and 5, 2. So this is our minor axis. So now, the graph of a hyperbola is different. You want to start off with a box. That box will basically encompass these two major and minor axes, conjugate and transverse axes, like that. And then you want to do the asymptotes. The asymptotes will be lines passing through the points of intersection, or not the intersection, like the corners of this rectangle. So it's like the diagonal. So this would be the first asymptote. Wasn't that bad? Look at her. She's getting a little better. And then the other asymptote will be this one. Boom. And then you could just sketch the hyperbola. Again, they're going to be horizontal. So it's just going to basically be, you want to make sure it touches that vertex and goes out like that. And goes out like that. And that's it. If you want to plot the focus, you can. Again, I'm not really a major stickler for that, but if you wanted to, here we go. So this would be, again, imagine it's 2.2. So 5 plus 2.2 is 7.24. So it'll be like right about here. And then the other focus would be 5 minus 2.2 was like 2.8. So it'll be right about there. All right, let's go to the next slide. All right, next slide. Here's our equation. And let's do what we need to. Why wasn't the eraser working on this one? Hopefully I don't make any mistakes because the eraser is not working. Anyway, so let's begin on this one. Orientation is going to be, because this is positive, it's going to be vertical. Again, it shouldn't really say orientation, it should say opens. It opens vertically. So it should look something like that in the end. This time the center is, again, this is H, this is K. Be careful with that. So it's going to be negative 1, 2. Our vertices, again, A, this time is the first time we're seeing this. With the hyperbola, it's different from the ellipse. A is 6 and B is 2. But A is under the X, so it's going to affect the H value, the horizontal value. So it's going to be plus or minus A, comma, K. And then it'll be H. Then it'll be K plus or minus the B value, which in this case is 2. So unlike this is one change between the ellipse and the hyperbola. In the ellipse, the bigger number was always with the one, like the direction it kind of opened or had the orientation for. That's not the case with this. So H is negative 1. So negative 1 plus 6 is 5, comma 2. Negative 1 minus 6 is going to be negative 7, comma 2. Now, the other one, covertices, it's going to be H, so that stays negative 1. And then 2 plus 2 is 4, negative 1. 2 minus 2 is 0. Now, the foci is going to be, again, c squared equals 36 minus 4. We keep them squared for that. So c squared equals 32. So c is the square root of 32. All right, and you can leave it like that. It's going to be approximately, again, if you wanted to think about how this would look in graphing terms, it should be 5.7. Hold on, let me text this fool to turn the TV down because it's mad loud. Turn it down. All right, anyway, back to this. Alrighty, so the focus is going to be, in this case, because it is vertical, that would affect the H, etc. But again, I don't really care about the focus. I'm not even going to stress about that. Let's graph. So for this one, again, we're going to start with the center. And our center is -1, 2. There we go. And our vertices are going to be 5, 2, and -7, 2. Okay, so that's our major. And then for the co-vertices, it's going to be -1, 4, and -1, 0. That's our minor. All right, so let's make our box. So it'll be like one line. It'll be one line here. Comes down here. And it's gonna like box off those. And then we make our asymptotes. Our asymptotes will be, again, passing through these endpoints of the rectangle. So this would be, oh, I missed it. That's one asymptote. And this will be the, I'm missing that one too. The other asymptote. Hopefully you guys do better than me. It's much easier on paper. And then you'll draw the two parabolas, for lack of a better word. And this will be, actually, I want to go closer to the lines. You want to go closer to the lines because it is going to be like right on the lines. But this is the vertex. And basically it'll look just like that. And this is the vertex kind of it. And it'll look like that. But again, you want them to be really close to those. That one at the top looks pretty bad. I could do a little better. You want it to be really close to the lines. Yeah, something like that. Looks a little better. All right. Any questions? All right, next. All right, one more. Now, this is one of the ones from the graph, from the table. So this is going to have vertical orientation. Not orientation, but opens. The center for this one is going to be 5, -2. Let me change my pen point because this one is worse. Makes my handwriting look way worse, which is not really possible. Anyway, and so let's do the last piece. Vertices. All right, so this one, this is our A. Oh. This is our A, with the graph a little early there. But for the vertices, it's going to be H, comma, K, plus or minus the square root of 3, because that's what A is. And this will be H plus or minus B, which is 1. Since I wrote the square root of 3 there, I'll just write 1, which is 1, comma, K. All right, so the square root of 3, if you want to find the decimal, I think it's like 1 point, I don't even know, square root of 3. I was going to say 1.7, so good. Square root of 3 is like 1.7, so if you're plugging that in here, this would be H is 5, and then this will be -2 plus 1.7, that'll be -0.3, then it will be 5 minus 3.7. So that's roughly what that would look like. The co-vertices are going to be 6, -2, and 5 minus 1 will be 4, -2. The focus, or the foci, in this case would be, this one was vertical, right? So it was going to be H, K, plus or minus C. C for this one is 3 minus 1. So that's going to be c squared equals the square root of 2, which is like 1.4. So the h, which is 5. And then this would be -2. I'm just going to write it. -2 plus or minus the square root of 2. I'm just going to leave it like that. And then let's graph. So for the graph, we start with the center. 5, -2. 5, -2. Then we go to 5, -0.3. So right about there. All right, and then 5 and -3.7. Right about there. I keep bringing up something like that. That's not the best looking, but that's going to be the major axis. And then the minor axis is going to be -6, -2. Oh my gosh. And then it's going to be then it's going to be 4, -2. All right, so we would draw our box. It's a small box for this one, but it will look something like that. Again, you draw your diagonals going through here. Those are asymptotes. And here. All right. And then here's the other one. Oops. Oh, no. Nope. Doing the most right now. All right. Sorry. And then this one. Let's see. Something like that. All right. So those are two asymptotes. And in this case, again, the y was the thing that was squared. So that meant it was going to open up and down. So this is like the vertex of the top parabola. Use the bigger pen here. And like this would be basically how that would look. Again, you don't want to actually touch it, so my bad there. But it should get really close to the line. Something like that. All right. And here's the last slide. The last slide will be writing the equations of the hyperbolas. This will be very similar to what we did with the ellipses because we have that coefficient that's not 1. So let's start that process. So first thing I would do is get my x's and my y's together. The y is the one that's positive, so we'll put that one first. Minus 54y. Then it's minus 4x squared. And because this is a positive here, and we're kind of, whatever, I guess we can say it like this for now. It's fine. I'll just keep it without the parentheses. And then I'm going to move the 19. So it'll be a plus 19. Now, just like before with these, when you're completing the square, you have to take out the coefficient. It can only be a 1. So it has to be 9 on the outside. So y squared minus 6y. Just like that over here, I'm going to take out a -4, and then it'll be x squared minus 8x plus, oh yeah, minus, because the negative times the negative will give us a positive, equals the 19. And then I'm going to focus on completing the squares. So this will be 9y minus 3 squared. Again, over here, we're going to add the like extras we need. So -3 squared would have been 9, but again, we're multiplying that by 9. So it's really going to be 81 that I'm adding over here. And then minus 4x minus 4 squared. So for this one, -4 squared is 16. Excuse me. But again, I'm going to end up multiplying that by a -4. So it's going to be so 16 times -4 is actually going to be -64. So I want to subtract 64 over here. Because again, whatever I do to one side, it has to do the same thing to the other side. So it'll stay equal. So in this case, because it's a minus there, unlike normal, we always add it. We're going to subtract it. All right, so this will be 9 y minus 3 squared minus 4 x minus 4 squared equals 19 plus 80. 81 is 100 minus 64. That's going to be 36. Now, can't have a 36 over here with the hyperbolas. We need it to be 1. So we divide everything through by 36. So this is going to end up being final answer 1/4. I'm going to do it in black. This will reduce to 1/4. So it'll be y minus 3 squared over 4 minus, this will reduce to 1/9. So it will be x minus 4 squared over 9 equals 1. Final answer. That's a 9. All right, next problem. And final problem. All right, so I'm going to erase this just so it's out of my way. And let's do it. Last problem. All right, so let's group them. This time the x squared is positive, so I'll keep that first. 25x squared minus 100x. And then I have the minus 4y squared. And the plus 48y equals 144. Again, I'm moving that over. All right, so this time GCF is 25, x squared minus 4x. This time GCF is a negative 4, y squared minus 12. Excuse me. Keep on going. So at this point, I'm going to complete my square. It'll be x minus 2 squared. But again, I'm multiplying that by 25. So over here, I need to add. So this would have been 4. And then 4 times 25 is 100. So over here, I'm going to put plus 100. Next, we'll move on to this one. It'll be negative 4 y minus 6 squared. Now, the 6 squared is 36. But then the 36 times 4 is 144. And that's a negative. So I need to subtract that from over here. Equals, that's going to end up being 100. Divide everything by 100 because I don't want 100 over there. I want a 1. And then I can simplify everything out. This will become 1. This will become 4. This will become 1. This will become 25. So it becomes, final answer, x minus 2 squared over 4 equals, minus y minus 6 squared over 25 equals 1. All right, that was a little longer than I intended, but that's our hyperbolas. Have a fabulous weekend.